The meters we are delivering into the rollout of Netz Burgenland are so-called FCC ready. So currently the FCC band is not yet allowed to be used in Austria. The reason for that is that the frequencies defined in the FCC band can interfere with air traffic control, which is why the usage of those is still restricted. Nevertheless, the meters we are delivering are able to be switched manually, meaning locally via the PDA or optical interface, or then remotely via upper system, being it the head-end system, or then even the MDMS system to be scheduled or case by case. So this is our solution, which is currently under test. So we are testing, or we have been piloting the FCC communication in pilots within Switzerland. We have been in contact with the respective regulatories notching certain frequencies. So where we have been seeing disturbances or noise, or we have been notching or blending out frequencies of the FCC band in order to comply with the requirements of the other parties using the same bandwidth. Right now, Austrian energy community is also doing field tests to identify and set the targets and frame conditions for using the FCC band in Austria. So right now, in this very moment, weeks and months, we are doing field tests with the customer, with Netz Burgenland, on behalf of this Austrian energy, and doing those tests together with specialists in Austria. What does that mean? Or another picture, perhaps a slide for the FCC and G3 for what it means for Netz Burgenland and the rollout. I think when we compare with the earlier PLAN technology, the G3-PLC offers an increased bandwidth, which is certainly necessary to cover the additional functionality, being it security or demand and response functionality for the load management. On top of that, the communication with the data concentrator is established much quicker, which allows then a faster rollout, a faster, shorter time to tackle communication and technical issues in the field. On top of that, and I think that's the nicest part here, is that showing visualized on the next slide, G3 offers a dynamic visualization of the routing. So that means the meter registration process is very much improved compared to the earlier PLAN technology. So each meter delivers communication statistics and quality data, enabling routing data, enabling an upper system, in this case here the data concentrator web user interface, to display and manage the communication network. So each green dot you see on this graph is representing a node, a G3 node or a meter. The color, in this case, a good situation, a dark green, is the communication quality. The distance between the green dots is the attenuation between the nodes, and the thickness of the line identifies the amount of traffic flowing. So you can imagine that this changes throughout the time as the situation and figures are never stable. But this enables then a faster identification of the troublesome meters, or where we perhaps have sources of noise, and together with a geographical information system with showing photographs, you're even able to perhaps identify the source of the noise if it's, for instance, a PV station. That allows most of the troubleshooting to be done remotely, and then speeds up also the time needed, or shortens the time needed to find the noise sources on site, even though that we found out that G3 is much more robust in regard of noise, and especially now with the FCC band, we can see with the first pilots that even more the impact on noise is nearly eliminated.